Hello everyone, I'm Dr. Rosemary Mardling here in the School of Physics and Astronomy, and I'm one of the astrophysicists who likes to study exoplanets and how they interact with each other through the gravitational field. And actually this demonstration today has a lot in common with exoplanets revolving around their stars. So let's think about this. Here's a wheel hanging off a metal whatever. If I pick it up, what will happen? You know what will happen, it'll just swing back and forward. Why is it doing that? Gravity is trying to pull it back down. It's just acting like a pendulum. But what happens if I tip it up again and spin the wheel? What will happen if I let go? Will it fall down? No, it does not fall down. It spins around its axis, and the axis itself precesses around the axis, around the vertical. So what is going on here? Why doesn't the wheel fall over when it's spinning, and it does fall over when it's not spinning? So I'd like to show you something familiar to explain to you what is going on. So let's try and understand why the spinning wheel defies gravity. Let's start with something that we're all familiar with and we kind of accept because it's just something we've been seeing sort of all our lives, and that is the spinning top. So if let's say here's a tabletop, and I take my little top, and I'm not spinning it. If I try and stand it up, let me try and draw a top. I've often drawn something like that. Okay? And if I just stand it on the table, what happens to it? Well, it usually falls over. If I could put it perfectly upright, and if the top was perfectly symmetric around this axis, it would just stand there. But the slightest little touch, and what happens? You know what happens, it falls over. Because, well, let's say that it was slightly off axis. Let me get a different colour. Say I stood it up a tiny bit away from the vertical, it would tip over that way. We all know that, we've seen that happen. On the other hand, if I spin the top to start with, and we never get it perfectly standing up, the top doesn't fall over unless I haven't spun it fast enough. So what's going on? There's something called angular momentum, which I won't really talk about, but the angular momentum is, for those who've done a bit of physics at school and vectors, the angular momentum is a vector in the direction of the vertical that it's spinning around. What happens to the top if it's a little bit off the vertical? It precesses. So if it's spinning around this direction and it's tilted a little bit, it spins around that direction, and then that direction itself slowly moves around like that. Well, this is basically what we're seeing over there. The reason why the top doesn't fall over when it's spinning is the same reason our gravity-defying wheel doesn't fall down when it's spinning. And also we notice that the spinning wheel precesses around, around the vertical, just like our top does.